Hi guys, my name is Shubhang, Chemistry Master Teacher at Vedantu. Today we are going to talk about KVPY 2020 paper 12 standard part 1 and the chemistry section. Specifically, we are going to talk about question 16. The question says, which of the following square planar geometry is exhibited? For exhibiting square planar geometry, we know that the hybridization has to be DSP2. That means which electronic configurations are not allowed? A D10 configuration is definitely not allowed. In rest other cases, we can still have strong field ligands, pair up electrons, get square planar. But in D10, we can definitely not get square planar. So let's go ahead with that thought ki D10 aayega ki nahi. Probably we'll have our answer. So let's start with cadmium. We have cadmium 2 plus here, as you can see, oxidation state is 2 plus. Cadmium belongs to zinc family. It's zinc, cadmium, and then mercury, right? That means NS2 and N-1 D10 configuration. So cadmium 2 plus will be 4D10. 4D10, so it cannot form DsP2. Similarly, here you have zinc 2 plus. Zinc 2 plus will be 3D10. If it is 3D10, again, it cannot form DsP2, so it cannot be square planar. Next, we have copper plus. So copper ka configuration in ground state is argon 4s1 3d10, right? So therefore, copper plus ka electronic configuration will be argon 4s0 3d10. So again, a d10 configuration cannot be our answer. Next, palladium. So palladium belongs to nickel family. We have nickel, palladium, and then platinum. But palladium also has a special electronic configuration, right? Palladium का जो special electronic configuration है, that's krypton 4d10. Implies if I have to make palladium 2 plus, the configuration will be 4d8. Let me just capitalize this P for you. So palladium 2 plus will be 4d8. Now, palladium 2 plus and platinum 2 plus have this special property, guys. Even if WFL is present, they will still pair up electrons and you will have inner orbital complex forming up. Let me move this for you on the next slide. What I'm saying is palladium 2 plus, sorry, not PB, palladium 2 plus and platinum 2 plus, even if we have WFL, it will behave as SFL. That means we have to induce pairing in order to form inner orbital complexes. Implies platinum 2 plus, palladium 2 plus, which are D8 configurations, which in general will have non-empty d orbitals, right? Which in general will have non-empty d orbitals like this, will automatically, whether it is an SFL system present as ligand, whether WFL, the electrons will always get paired up. So platinum 2 plus, palladium 2 plus के coordination number 4 complexes are always square planar. Remember this, guys, very important fact. Now, can these complex K coordination number 6? What about their coordination number 6? Do you see that even if I've paired all the electrons in platinum 2 plus and palladium 2 plus, I cannot form D2sp3. There are no 2d orbitals empty. So when it is coordination number 6, this will definitely be sp3 D2. Okay. But if we now have palladium 4 plus and platinum 4 plus, which will be a D6 system. So the same thing is valid whether you have WFL or you have SFL, it will always pair. Okay, it will always pair and then answer will be D2sp3. So be careful with respect to palladium 2 plus and platinum 2 plus complexes. Coordination number 4, always inner orbital, always square planar. Coordination number 6 with charge 2 plus at the cation outside sp3d2 because no vacant orbitals, not enough vacant orbitals. Okay, what about platinum 4 plus, palladium 4 plus, D6 configuration, electrons will always be paired, so it will end up forming inner orbital complex, that's D2sp3. So coming back to our question, hence our answer is palladium. Thank you so much for joining us, guys, and stay tuned for our next question.